Good morning, sir. Myself, Y Madhu. I am from Triple Department. Today, my topic is power factor in synchronous motor. Firstly, introduction to synchronous motor. Synchronous motors operate at a constant speed and are widely used in industrial applications. They require an external DC source for excitation to produce a magnetic field. Understand excitation levels is crucial for optimizing performance and efficiency. Basics of excitation in synchronous motors. Excitation refers to the process of supplying current to the rotor winding of the motor. The amount of excitation directly affects the motor's magnetic field strength. Proper excitation is essential for controlling the performance of the motor under varying loads. Effect of under excitation. Under excitation occurs when the rotor receives less DC current than required. This condition leads to a lagging power factor which can result in increased line current. Under excited synchronous motors may draw reactive power from the grid, stressing the supply system. As shown in the figure is a gravitational rectifier in the diagram shows in effect of under excitation. Effect of over excitation. Over excitation happens when the rotor receives more DC current than necessary. This condition results in a leading power factor which can improve system efficiency. Over excited motors can supply reactive power back to the grid, benefiting the overall power system. Relationship between current and excitation. The excitation level influences the armature current drawn by the motor. Higher excitation leads to decreased armature current under certain loads conditions. Conversely, insufficient excitation increases the armature current, potentially causing overheating. Power factor and its importance. Power factor indicates how effectively electrical power is being converted into useful work output. A power factor close to unity is designed for efficient motor operation and reduced system losses. The synchronous motor's power factor can be adjusted through changes in excitation levels. Current regulation through excitation control. Excitation control systems help regulate the current drawn by the synchronous motors. By adjusting excitation, operators can maintain optimal performance across various load conditions. This regulation helps to prevent motor overheating and potential damage to electrical components. Case studies on power factor improvement. Numerous studies have shown that proper excitation levels can significantly enhance power factor. In industrial applications, maintaining an optimal power factor can lower electricity cost. Implementing excitation control strategies leads to better energy efficiency and compliance with regulation. As shown in the diagram, we show case studies on power factor improvement, active power, reactive power, reactive power. Challenges in excitation control. Variability in load conditions can complicate the maintenance of optimal excitation levels. Faulty excitation systems can lead to unstable power factor and increased operational cost. Continuous monitoring and adjustment are necessary to ensure constant performance. Conclusion and future directions. The effect of excitation on current and power factor is critical for synchronous motor performance. Future advancements in excitation control technologies may lead to even greater efficiency. Understanding these dynamics is essential for engineers to optimize motor applications in various sectors. Feel free to modify any content or format to better suit your presentation style. Thank you.